Now in this video we're going to find the true shape of our cutting plane AA. We have an auxiliary view over there which we used for our other views, for our top view, which I'm now going to get rid of because I'm not going to really need it for finding our true shape anymore, and it's just going to get in my way. So I'm going to take that out, and to find the true shape of the cutting plane we now need to project off of our cutting plane AA here in the front view, and we have to do it at a 90-degree angle to that cutting plane, because that cutting plane over there, they're very kind to us in this question. Okay, if you have a look at the question over here, you see in this question they've been very kind, they've actually told us what the angle of the cutting plane is, the 60-degree angle. So because we know what the angle of the cutting plane is, it makes it a lot easier to project over it at a 90-degree angle. So we know that if we put 60 and 30 degrees together, we get 90. So because this is at a 60-degree angle, we can put our 30-degree set square on there and project over it, and we'll know that each of our projection lines will form a nice 90-degree angle over there with the cutting plane. So we're going to project all of the points of our cutting plane out. Okay, and remember it's only the points where the cutting plane hits into the shapes that's cut. You don't project any of the points that actually belong to the shapes themselves. That's not necessary at all. Only your cutting points get projected. And then once we can projected all of those cutting points, I need to go and draw in a new XY. Okay, and this XY we're going to go and draw in parallel to our cutting plane. Okay, so they're parallel to the cutting plane. We're going to push it, doesn't matter what measurement it is away. Okay, we're going to push it just to make sure that it's off of the rest of the drawing. So we're going to put in an XY line over there, okay, to use to project over. Now because we're going and projecting over a new XY line there, we're going to go one XY line back. Okay, as usual for our method, we're going to go one XY line back, and we're going to take our measurements from the other side of that XY line. So our next XY line back, okay, from there, one XY line back is here, and we're going to take our measurements from the XY line this direction, and we're going to plot them over that XY line. So watch carefully. If we take the first side point over here, point 4 there, we're going to go and measure how far point 4 was away from our XY line. Okay, point 4 there was 7 millimeters away. Okay, so 7 mils away there. We're now going to take that 7 millimeters, and we're going to go and find that cutting point there. See where it's been projected across, and we're going to go and measure 7 millimeters over the XY line on our projection line. We're going to mark off that. Then the other point that it cuts there, remember there were 2 points there, not just one, it was 2 and 4 that it cut on. So we've done 4's measurement, we need 2's over here, so we're going to measure again from the XY line down, that's 55 millimeters. And then I'm going to go and find, it's on that same line there of course, and I'm going to measure from the XY line up there, 55 millimeters, mark that off. Okay, be careful to make sure you're always measuring from the XY line to the point. Never go and measure from this line here, because then you're changing things and your whole drawing will, your whole true shape will go out. Okay, so next point, that point over there, okay, where it cut on line 1 and line 5. So I'm going to follow that down. I need a measurement here. That of course is going to be 7 millimeters again, and then 55 millimeters in the end. So I can go and measure my 7 millimeters here, mark it off, and I can measure my 55, still always from the XY line up on my projection line. Okay, and there I've got my next 2 cutting points. Okay, then the next one was where it hit on to line 6, okay, so it's on this line here to that cutting point. So I'm going to take that measurement, okay, and that is 31 millimeters. And then I'm going to take it from where it hit on line 6, and that line that was projected across, and I measure from the XY line up on the projection line 31 millimeters up and make my point. Okay, then next one, that completes the sectional plane for the hexagon, so I can go and draw that in dark. Ready? That's all you need for that cutting plane. Simple as that. Okay, so that now gives me the true shape. That's the true shape of the cutting plane on the hexagon. And now we're going to find the true shape of this little one. Okay, so again, taking measurements. Let's go find this point over there first, from my XY line to that point. Okay, from XY line to the point, that's 28 millimeters. Okay, so now that point, if I follow it up on its projection line, there's its projection line. I'm going to measure from the XY line 28 millimeters up and mark it there. Then next point over here, I can take its measurement from my XY line to there. That I measured as, that says 43 millimeters. So I'm going to take that up. There's its projection line. So I can go and measure 43 millimeters from the XY line up. Mark it. Next one over here, I can measure from my XY line to that point, that's 33 millimeters, and I take that up and across. So from my XY line, 33 millimeters on that line, and then the second point's on the same line, so I've just got to go measure that. That's exactly 20 millimeters away. So I go on that same line, and again from my XY line, 20 millimeters away. Mark that point, and then all I have to do is check first. Go 1, 2, 3, 4 points. 1, 2, 3, 4 points. So now we can go and join them all, and that'll give us the true shape of that cutting plane. I know it looks really strange, but that's 100% correct for both of those cutting planes. And then the last thing that you have to do, again, because they are cutting planes, you have to go and draw in 45-degree hatching lines. That's a must. And again, we've got a big surface, so we can go to a max of 7 millimeters between each of these 45-degree hatching lines. Okay, there we have it. Our complete drawing with our sectional top view, sectional right view, and then the true shape of both cutting planes.